Hello there, this is Miss Nakayama, and today's lesson is 11.8 Surface Area and Volume of Spheres and Applications. So we have three formulas that we just need to talk about, and then we're going to work some problems, so make it short and sweet. So the first one, surface area and surface area formula. Okay, it is 4 pi r squared. Volume is 4/3 pi r cubed. Y'all, area is always squared. So we got the r squared for area. Volume is always cubed, r cubed, and we got the 3 there also. And then we have density, which is weight divided by volume. So first off, let's find the surface area and volume of each sphere. So to start off with, our surface area, again, 4 pi r squared. So what is my radius? You can see from our picture, it is 5, and that makes the answer 100 pi square inches. Then to go find our volume, 4/3 pi r cubed. What is my radius? It is 5. So 5 cubed on your calculator, y'all. 5 cubed is 125 times 4 is 500. So it's 500 pi over 3 cubic inches. And if you put the 503 and put the pi up front, it doesn't matter. Okay, number 2, we have a sphere with a diameter of 24. So my surface area formula, 4 pi r squared. What is my radius? Not 24, it is 12. And 144 times 4 is 576 pi meters squared. All right. Volume of this sphere is 4/3 pi r cubed. My radius again is 12, so I'm going to plug that into my formula and punch that in, 2,304 pi. Oh, look at that. That should not be squared. That should be cubed. All volume is cubed. All area is squared. Okay, got that one right. All right, let's look at the next one. Pretty straightforward with a picture, but let's make sure we know what to do with words. What is the volume of a hemisphere with a diameter of 41.6 meters rounded to the nearest tenth of a cubic meter? So it asks me for the volume of a hemisphere, y'all. So a hemisphere is going to be half of a sphere. So when I write that, I'm going to put the 1/2 times the volume of my sphere. So when I put that down there, 1/2, 4/3 pi r, what is my radius? Well, my radius is half of that, which is 20.8 cubed. And when you punch that in, and y'all, you should pause this. If you think this is really easy, pause it. Go fill out the notes and then check your answers. That will give you a much better understanding of this lesson. All right, so my rounded to the nearest tenth, that gives us 18,847.3 cubic meters. All right, number 4. What is the radius of a hemisphere with a volume of 8,231 cubic centimeters? That thing's supposed to be a little cubic centimeter. To the nearest tenth of a centimeter, what is the diameter to the nearest tenth of a centimeter? So they asked for the radius, and then they asked for the volume. So same formula we just used. Volume is 1/2 of the volume of a sphere. There's the volume of the sphere, so the hemisphere is just half of that. Now I'm going to go plug in what I know to find what I don't know. Okay? And in this formula, I'm looking for the radius, and I know the volume is 8,231. So we've talked about this a lot. I'm going to multiply by the reciprocal, which is, this is 4/6. The pi is on top. So when I multiply by the reciprocal, it's like 4 pi over 6. So it's going to multiply by that reciprocal is going to be 6/4 pi. So I'm multiplying both sides. Well, when I multiply the right side times 4/6 pi, this is all going away. Boom, boom, boom. Right? That cancels out. Then you got to know 8,231 times 6 divided by 4 pi. And if you don't have the horizontal fraction part, you have to put parentheses around that 4 pi. And so that gives us 3,930 point blah, blah, blah. That's r cubed. If you're going to the nearest tenth of a meter, y'all, you don't round to the tenths until the very end. And I would encourage you to go further than that. So now we would take the cube root of both sides. That's doing this. Cube root. That doesn't really look like a 3, sorry. Cube root and cube root of both sides. Make sure you know that button on your calculator. So R equals 15.781, which of course on your in Delta Math you would say that's 15.8 centimeters. Okay, so that's the radius. What's the diameter? I'm going to double this number because you got to see how it is. But if you double that number, you're going to get a diameter that's 31.6 centimeters. Okay? Number 5, a block of wood, 3 centimeters on each side, has a weight of 27 grams. What is the density of the block of wood? All right, my formula for density is weight over volume, weight divided by volume. So in this case, I know the weight is 27 grams. So if I plug that in, 27 grams, what's my volume? Well, it is a block of wood that's got the same dimensions on every side. So that's a cube. Volume of a cube is just edge cubed. 3 cubed is 27. But you want to keep the units in here, y'all. It just keeps your problem straight. So that's 27 cubic centimeters. So if you simplify that, that means that your density is just 1 gram per cubic centimeter. That's how you answer a density problem. Okay? Number 6, what's the volume of a marble that has a mass of 3 grams and a density of 2.7 grams per milliliter? So same formula, density equals weight divided by volume, but I'm plugging in what I know, okay? And this time I know my density, so 2.7 is equal to 3 over the volume, and that's what I'm looking for. So we talked about this a lot when we did our trig problems and stuff. If the variable's on the bottom, I can just switch these two. So that means that V equals 3 divided by 2.7, whichever your calculator is tells you that that's 10.9 milliliters, because that's the volume. This is the volume, and this is the weight, which is why the density has both. So 10/9 milliliters, if they asked you to carry that out, it would be 1.1 milliliters. All right, number 7. Just 2 more, y'all, real quick. An aquarium in the shape of a right rectangular prism has dimensions of 110 times by 50 by 70. Given that 1 cubic foot is equal to 7.48 gallons, about how many gallons do you need to fill the aquarium? So clearly I have to find that volume first. So the volume is area of the base times the height. So what is my base? I mean, it doesn't really matter, y'all. I just picked the first 2 numbers. Okay, so that's 100 times 50 and then times 7. You just multiply them all together. That is 38,500 cubic feet. Here is your conversion factor right here, y'all. Okay. So what you have to remember, if I want to know how many gallons, if I'm going to gallons, I'm going to put gallons on top and cubic feet on the bottom. So I'm going to multiply, and then when you do that, you're going to see, hopefully, that your cubic feet cancel out, leaving your answer to be 38,500 times 7.48 to give you a total of 287,980 gallons to fill the aquarium. All right, last problem. A cylindrical container has a diameter of 16 feet and a height of 14 feet. Nope, of 4 feet, my bad. What is the volume of the cylinder? So we remember that volume of a cylinder formula, which is pi r squared h. And I know r and I know h, so I can find the volume. So what is my r? R is half of my diameter, so that's going to be 8. My height is 4. So I plug that in and I get 256 pi. But y'all, this is a word problem, and in a word problem, most of the time they don't want an exact answer like that. So you would put that in your calculator, 256 times pi, and that would give you 804.25 cubic feet. That is all I have. Thank you so much for watching. If y'all have any questions, please don't hesitate to email me or come see me. Y'all have a great day.